The graph of y equals 1 over negative 2x squared minus 0.5 was reflected in the x-axis and its image is shown. So there's a lot happening on this sentence right here. First of all, this is not this graph. We have a graph after it's been reflected in the x-axis. A couple of things about reflected in the x-axis. If you're reflecting in the x, things are changing vertically. So that's a vertical reflection. If it's a vertical reflection, we can say that that is outside of the function. So we can sort of write things in function notation. That negative would be outside of the function. What is the equation of that red graph? Well, if this was my original graph, and I need a negative outside of the function, okay, I'm going to think of my equation will be negative, and I know there's no f of x written, but that's what the function notation would look like. That means my whole original equation, there's a negative in front of it. So one way that I could write the equation of this red graph is to say my whole original equation, which was this, could have a negative out in front of it. Now that's not simplified, but that is correct. Because I had a reflection, a vertical reflection, the negative would be outside. This is what it would look like. Now I'm going to test your algebra skills a little bit, and I'm going to simplify that, maybe right, maybe wrong, in 3 different ways. And you're going to have to decide if all 3 are right, all 3 are wrong, or is 1 right and 2 wrong, 2 right and 1 wrong. That's what you're going to have to decide. So I'll write down simplifications of this algebraically in 3 different ways. You decide which one's right, which one's wrong, or whether they're all right or all wrong. Am I making you think too much? Okay, here we go. Number 1, in blue. Number 2, in green. And number 3, in black. So what I've tried to do is take the red graph, the red equation here with the negative outside the brackets, and I tried to simplify it by not having the brackets. And I gave you 3 possibilities. They could be all wrong, all right, or maybe only 1 is right, or maybe there's 2 that are right. That's what you have to think and try to decide at this moment. For those of you in the 25, the 1 correct, 2 wrong, we now have to figure out how many people think that blue is correct, how many people think green is correct, how many people think black is correct. And these numbers have to add up to 25 now, or else we have a quiz tomorrow. Okay. Blue. The blue is correct. Show of hands. Okay. Interesting. The green is correct. Oh man, I can start 1, 2, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 20 on the green. The black is correct. Did I miscount? Uh-oh. Did someone not vote? Maybe I counted. We'll give you guys the benefit of the doubt. I'll say 21 here. Okay. And now, the moment you've all been waiting for. The blue is correct. The green is wrong. And the black is correct. So there are 2 correct and 1 wrong, but it goes to show that when we simplify in algebra, as you guys have demonstrated, it is quite easy to make some mistakes. First of all, most of you thought only 1 was correct. In fact, there was 2 correct. And then of the ones that you thought were correct, you picked the one that wasn't correct as the one that was correct. Whew. So what went wrong? Well, let's look at this to understand a little bit more, because it's a common, obviously, I showed you statistically, it is a common mistake because most of you made it. What does a negative outside of a fraction mean? Okay? If I did it easy, I just took a regular fraction like a half and I put a negative out in front. That's negative a half. It's equal to negative 1 over 2, correct? It's also equal to 1 over negative 2. Because having a negative multiplied in front, you could change that negative to a fraction. That negative out in front is like a negative 1. How can I write negative 1? I can write negative 1 as negative 1 over 1 times a half. That would multiply my numerator by the negative 1, making my numerator negative, and keeping my denominator positive, correct? Or I could have made my negative 1 out in front, 1 over negative 1, which if I multiplied my numerators, I'd get 1, and negative 1 times 2 would give me negative 2. So looking at our example, that negative out in front, you could think of that negative out in front as a fraction, 1 over 1, with the negative on top. If the negative is on top, can you see that I would get negative 1 on the top? My bottom would stay the same. That is why the blue one is correct. Okay? I could have also had that negative on the bottom, 1 over negative 1. If I did that, 1 times 1 would stay 1 on top, and here I'd have to distribute my negative, right? And then this would become positive, so my black one is correct. What happened in the green one? We just over-distributed negatives. You can put the negative on the top, put the negative on the bottom, put it everywhere. Okay? What does that end up doing? It's like multiplying by, if I multiplied by a negative on the bottom and a negative on the top, well then I've actually multiplied by a positive one and didn't change anything. And so that is why the green one is wrong. But it's good to see that again, because, I mean, it's straightforward multiplying by fractions, but sometimes those ideas that we've known for a long time, we mess them up when we're dealing with a situation that's more complicated. Now, if you were asked to write your final answer for this question on a test, you could have left it in red just like we had at the beginning. The whole thing in brackets with a negative out front. That would be correct. But if it was a multiple choice question where they gave you possibilities to choose from and it had been partially simplified, you are expected to know the algebra on how to do that. So that's why we reviewed it now. Okay, your questions for this last one are 7, 8, 9, and 12, and we're going to start tomorrow's class talking about number 12, because number 12 is an example of how a question can be worded differently, and they'll do this on your exam, but you have the tools to figure it out. So it's a little bit more challenging, and so I want you to make sure you've looked at number 12 before class tomorrow.